Good morning. This is Tom Stack, Vice President of Sales and Business Development for Fiorano Software. And it gives me great pleasure to welcome you to today's Fiorano webinar, Integrating Microservices in the Cloud. I'd like to start by welcoming our speakers, Jason Bloomberg and Atul Saini. Our first speaker, Jason Bloomberg, is the leading industry analyst and expert on achieving agile digital transformation by architecting business agility in the enterprise. He advises business executives on their digital transformation initiatives and strategies and trains architecture teams on agile architecture. He is the author of highly regarded publications, The Agile Architecture Revolution and Service-Oriented or Be Doomed, How Services Orientation Will Change Your Business. Jason will strip away the hype from microservices and clearly identify their advantages and disadvantages. He will then discuss the role of microservices play in cloud-enabled enterprise integration. Our second speaker today is Atul Saini, who is the founder, Chief Executive Officer, and Chief Technology Officer for Fiorano Software. In 1995, Atul pioneered the vision of bringing an architectural revolution to business integration. For over 2 decades, Atul has been at the forefront of integration and SOA with continuous product innovation from the inception of messaging middleware in the mid-90s to present-day peer-to-peer distributed processing. He is also one of the first technologists to realize the power of microservices, a core design in critical architectural decision in redefining today's digital world. Atul will explain in detail how to connect microservices securely across cloud and on-premise implementations, and how Fiorano's peer-to-peer microservice-centric infrastructure platform solves the most challenging integration problems. I'd like to welcome Jason, and he will take it from here. Thank you very much, Jason.
Well, thanks a lot, Tom. It's a pleasure to be here. And let us get started with integrating microservices in the cloud. So a bit about me. I'm president of Intellix. We're an industry advisory firm that advise companies on digital transformation initiatives. I also write for Forbes and occasionally from Wired, but you may be most familiar with me from my work for Forbes. And there's my latest book, The Agile Architecture Revolution, as well. So let's get right into it. So what are microservices? Well, the best definition I have seen is essentially defining them as fine-grained units of execution. So they are essentially elements of code, programmable code, that can do one thing and do it well. But it's more than just the code itself. It's the code and everything that you need to make that code work. So the operating system, platform, framework, runtime, and dependencies, all packaged as a unit of execution. So instead of the old days where we might have a servlet engine, and then we might run code on the servlet engine, and the servlet engine is on top of some sort of underlying persistence framework, we're bundling all of that into this unit of execution. Now, we also use the term microservice in the context of architecture. So microservices architecture, which is essentially the architecture best practices around leveraging microservices as these autonomous and modular self-contained units. So one of the key questions here on this definition is, what does that term fine-grain mean? Fine-grain units of execution. And I'll be talking about what that means. So the problem here is the word granularity is a bit of a vague term. Many different things can be granular in different ways. Basically, if you have any kind of thing that can come in different sizes, then you could think of granularity in terms of that thing. So what people generally think of when they talk about fine-grained microservices is having small amounts of code, essentially where the micro prefix came from. But that's not really what we're trying to talk about here when we talk about granularity. Granularity is better applied to the interface, how much information is sent or received when you interact with a service. So the illustration here at the bottom, right, a coarse-grained interface would be a microservice that sends or receives, say, a JSON file or perhaps XML. A fine-grained interface might send a single value or a very small number of values, and that would be an example of a fine-grained interface. So in this context, if you think about the granularity of the interface, well, we generally want our microservices to be coarse-grained because we generally exchange JSON messages in today's world. Not necessarily, of course, you have other options, but generally speaking, when we talk about a fine-grained unit of execution, we're not necessarily referring to the interface because we want the interface to be coarse-grained. So it's a little confusing, but once you pick it apart, it's not too bad. So when we talk about a fine-grained unit of execution, what we're really talking about is parsimony. Now this fellow here, he's Ebenezer Scrooge, so essentially the classic miser from literature. And this is essentially what we mean. We want to be miserly with our code. So how much code goes into the code part of the microservice should be as little as we can make it within the context of what we want the service to do. So how big should a microservice be? Well, as small as it can be, but no smaller, right? So it depends upon what you want the service to do. And how do you determine that? Well, essentially through an iterative process. So this is aligned with an agile context where we're refactoring our code. Refactoring means making adjustments to the code to make it better without changing the functionality of the code. This is something that any agile developer is familiar with. And you want to do this with your microservices. So within every iteration, with every sprint, you want to look at your microservices and ask, well, would it be better if it was smaller? Is there some extra stuff in there we can take out? And if so, then you should take that extra stuff out. You also want to ask if a microservice would work better if it should be split up into 2 or more microservices. And if so, then go ahead and do that. Now, if not, then leave it alone, right? Don't make it smaller simply because it's big, by some measure of big. Make it smaller because that would actually be better suited to the goals of the service itself. So it's not a general principle, make it small, it's make it as small as it can be within the context of what you need it to be. And that's essentially being parsimonious, right? Being miserly. You only want to put code in if you actually need the code, and otherwise you don't want to put any extra code in. So other principles that are very important with microservices is the story of doing one thing and doing one thing well. And this principle is called cohesion. And cohesion has actually been with us for decades, right? This was a principle of modular programming since the 1960s, the days of Smalltalk, when we first started realizing that there was a reason to build modular code as opposed to huge monolithic programs. And cohesion essentially means that in each of those modules, they want to focus on doing one thing. And if you want to do more than one thing, then think about coming up with different modules. We called them modules in the 60s, and we called them objects. Now we're calling them microservices, the same principle. Right? So on the left, we have a microservice that is doing lots of different things represented by those different shapes. That is low cohesion. Instead, what we want to do is we want to build microservices so each one does one thing and does one thing well, and that's also something you want to achieve during your refactoring. So if you identify a microservice and it's doing 2 different things, separate that into 2 different microservices or reorganize the functionality so that your microservices are doing one thing and one thing well. So one of the challenges here is that in the web services world, when we talked about web services, 10 years ago, back in the day, well, often web services suffered from low cohesion, right? We could have web services with many different operations, and a lot of times we'd have far too many, and they did a lot of different things, and that led to all sorts of challenges, right? So part of the story of microservices is a reaction to some of the challenges we experienced with web services back in the day, and low cohesion was one of those challenges. So even though we could have built web services to be very cohesive, and that was always a best practice for web services, in general, many times web services did not follow that practice, and that was one of the challenges many organizations faced with web services. So another key part of the microservices story is the story of containers. So you don't need containers to run microservices, and you don't need microservices to run containers, but the microservices definition was essentially created with containers in mind. That is the idea that we could take this unit of execution with the runtime environment as well as the caching mechanism and operating system elements as well, and put them together into a unit aligns with what we want containers to do for us. So So there's a lot of synergy between the notion of containers and the notion of microservices, even though they don't necessarily, either one really requires the other. So if you're thinking about a container-based approach, you're going to be dividing your operational environments into these horizontally scalable, elastic containers that are very lightweight and ephemeral, right? They come and they go. And then essentially you populate those with microservices that are now handling the application capabilities within the context of everything that containers can do for you in terms of the operational environment, in terms of instantiating them, scaling them, and deprovisioning them, and everything else we want to do with our containers. But we still have challenges. Well, we still have to deal with state information. I'll talk about that in a little bit. We have to keep track of everything, and that is becoming an increasingly important part of the problem. Right? The more little things we have, the more the challenge is management, right? Keeping track of everything and how they relate to each other, and how we, the end-to-end execution of our application is going to behave when we have many different microservices running in many different containers. So we're shifting the responsibility from monolithic code that may have some level of self-management to now, these small units of execution that are externalizing those management capabilities. So that's something we have to keep in mind. And then, of course, integration, the topic of this webinar, is especially challenging now because we're integrating more smaller things than we did back in the day. Right? So if you think about, enterprise integration, circa, 2000, what we had was a lot of these big monolithic applications, and we had these ways of getting them to talk to each other. And that was essentially enterprise application integration and how it was done 20 years ago. Well, now integration is really means something quite different. It's taking all of these very small units of execution, whether they're microservices or other capabilities that are scattered throughout the cloud-centric environment, and making sure that we have the end-to-end message flows and application interactions and data interactions that we require in an inherently dynamic environment. Right, things are being scaled up and scaled down all the time, and we need to connect things together and ensure that the end-to-end performance is meeting the needs of the business. So integration now is becoming especially challenging in this very dynamic world that really is this story of the cloud, but now we have containers and microservices that are following in the footsteps of cloud architecture best practices and saying, well, what we did with the cloud, with horizontal scalability, elasticity, and automatic recovery from failure, we can do at the application level as well. And we want to do that in many cases because we now get the benefits of horizontal scalability and elasticity that the cloud has always promised. But if we don't build our applications to take advantage of that, then we don't get those advantages. So I mentioned web services, definitely worthwhile making very clear the distinction between web services and microservices, because we're essentially using that word service in different ways. Right? The word service has now evolved in its meaning. So there's that's actually my 2001 book. Do not go and buy that. It has been obsolete since about 2003, but I'm just putting it there just because I had needed something to show off web services. So back in the day, when we first wrote that book, web services essentially were contracted interfaces, right? A set of XML-based standards for contracting interfaces and XML-based message formats, and that is really what we meant by a web service. It wasn't the software itself, it was the interface. And the goal of web services was to abstract the underlying software by creating these XML-based contracts following the WSDL standard, so that we could essentially establish interoperability across dissimilar types of software. And that was the goal of web services. Well, microservices are not contracted interfaces. They may have contracted interfaces, and they typically will, but the microservice is the unit of execution. It does include the underlying software as well as the rest of the container-centric execution environment, right? The runtime, the modular runtime environment, and the underlying caching that supports that execution, the unit of execution. So when we talk about the interface of a microservice, well, it's typically a REST-based interface. Not necessarily. You could have, say, a JMS interface or other specialized interface. Generally speaking, though, we have REST-based interfaces that are contracted via the uniform interface, right? We have basic HTTP verbs. Those now simplify the notion of a contracted interface. This is one of the benefits of REST overall over web services, and we're bringing that to the microservices story now, but taking it for granted, right? We sort of understand now that the software interfaces are generally REST-based, and so the notion that we have a contracted interface is just, part of the the price of admission now. It's not something that we have to focus on the way we did back in the web services days. Okay, so what about service-oriented architecture, or SOA? Well, you can think of microservices architecture as next-generation SOA. You could think of it as fixing a lot of the things that were wrong with the first-generation heavyweight middleware-centric approach, or you could really think of this as an evolution in implementing the appropriate approach to architecture, right? So back in the day, one of the big challenges with SOA, the reason why enterprises were implementing SOA in the first place was often to deal with a heterogeneous legacy environment, a number of the integration challenges and the agility challenges in the context of a heterogeneous environment, and so we expose these legacy assets as services in order to better integrate them and to compose them to support flexible processes. The problem with that was if we had this horrible legacy spaghetti mess on our hands, exposing it as services did not get rid of the underlying spaghetti mess, right? We call this lipstick on the pig, right? Simply putting service interfaces on a horrible mess doesn't make it any less of a horrible mess. You're just hiding the mess. And this was one of the big challenges with SOA as it was done, 10, 15 years ago. So what we really want to do is leverage the fundamental best practices that we were trying to achieve. We want to have highly modular code that supports these contracted interfaces, shared nothing code where we don't have any unplanned interdependencies. So we want to be able to deploy them easily, and we want to be able to leverage the benefits of the cloud. So we want to be able to horizontally scale them, and we want to be able to leverage, the elasticity and fault tolerance of the cloud. So the way I like to put it is microservices are really what SOA services, generally web services, should have been all along, right? They should always have been very cohesive, right? They should always have been horizontally scalable and shared nothing, very modular. In many cases, they weren't, but today we have the cloud, today we have containers, today we have REST-based interfaces. So as a result, and we've learned the lessons of SOA, so as a result, we're now able to better implement what SOA really should have been all along because we have all of these related best practices. And that's a very important way of looking at it. It doesn't mean you have to call what you're doing SOA. You can call it microservices architecture. That may be a better political choice, but we all know it's a service orientation best practices under the covers. Okay, so one of the challenges now getting to the microservices integration story goes back to a seminal article by James Lewis and Martin Fowler of ThoughtWorks. And this article, this 2014 article, essentially established microservices as a topic to discuss. This article really, that's what we mean by seminal. It became sort of the go-to article for what microservices were. And for better or worse, this article talked about smart pipes versus dumb pipes. And what they were getting at was saying that a traditional SOA environment where we're relying upon centralized middleware to handle all the business logic, that's what they called smart pipes. And there are challenges with that because it's centralized, it's not very distributable, it has single points of failure, it's not very cloud friendly, and there's all these issues with putting your business logic in the middleware, taking, say, a BEEPL engine, a business process execution language execution environment, and put it in your ESB. Well, that never worked very well, and the vendors who got it to work had to do all these extensions, and it was just a mess. And anybody who's worked with BEEPL knows that for the most part, it was a stepping stone to better approaches, but for the most part, BEEPL was a spectacular failure. And that's really what they're getting at. They call it smart in the sense that the business logic is in the middleware. But what they're recommending now is what they call dumb pipes, where you put the business logic where it belongs in the modular microservices, and now the integration fabric is lightweight, say, message queue-based middleware. Well, so that's sort of a mixed message here, because they're saying dumb is better than smart, which is just confusing a lot of people. What we really want to say is that we want to take a microservices-centric approach to integration that integrates microservices in the appropriate way and deals with many of the integration challenges that traditional first-generation ESBs didn't deal with very well. So, essentially what we want to think about, well, we want to think about integrating in this world of the cloud, right? So we have the notion of instances in the cloud, right? There could be virtual machines or there could be containers, and they're inherently ephemeral, right? They come and they go. They can go belly up at any time. So either they fail or you're scaling up and scaling down, so provisioning additional instances and then deprovisioning them. Either way, you don't necessarily know if a particular instance is going to be available, right, or is going to be up and running. So you don't want to have any, hard and fast point-to-point integrations, because the other endpoint may go away, and then what do you do? So you have to have an approach to integration that essentially is built from the ground up to support this ephemeral world of the cloud, which it means containers and microservices as well. You also have to realize that that synchronous behavior is becoming less and less appropriate for business-related situations, right? Fundamentally, we want interactions to be inherently asynchronous, because asynchronous behavior scales better, it's more resilient, and it represents better how users expect user interfaces to behave today. I call this the Facebook effect, right? We expect asynchronous behavior on the user interface, and as a result, there's really no reason to think of interactions in this cloud integration microservices world to be synchronous. You really want to have an asynchronous, fully asynchronous model in order to support the inherent capabilities of cloud integration. So, the final point is the notion of maintaining state. And state information has always been a challenge in the integration world broadly and in the SOA world particularly, especially when we start looking at those business process instances that we want to implement as compositions of services. We never really did get that to work very well, and part of the challenge was maintaining the state information. We have to keep track of every single instance, process instance, the business process instance, and where somebody is in their shopping cart process, and we had to keep track of everybody, and that became very difficult to scale. So the challenge here is we want to be able to maintain state in a horizontally scalable way, so if an instance goes down, we don't lose any state information. The last thing you want is to have some sort of instance failure, whether it's a container or a virtual machine, bring down a shopping cart in progress, right? Because then you lose the purchasing transaction, and that's what the business wants to avoid. So how do we deal with that? Well, caching can be part of a microservice, and so each microservice can individually maintain its own state, right? Because it can put state information in its own cache, but we still don't want to rely overly too heavily on each microservice's caching mechanism, because we don't want to lose state information if a particular microservice instance running in some container has a problem. Either it's not available or it fails. So we need to have a better way of maintaining state information. The key here is to maintain state in the messages. So if a message is going to a container that has a microservice running in it and the microservice fails, well, the state information isn't lost because we put that message in a queue, and the queue has built-in reliability. But we need to be able to scale our queues, because a queue is in and of itself is a point-to-point mechanism, so we can't rely solely on queues because they don't horizontally scale all by themselves. So this transitions well to the Fiorano story, because this is what they've been doing all along, is managing state information in messages, leveraging a microservices approach that is able to scale queuing mechanisms horizontally in order to address all of these integration challenges. So that's why I put this slide toward the end, because it's great transition to the Fiorano content. So this is my final slide. There's my contact information. And if you send an email right now to Fiorano@intellix.com, of course, you can send it later, you'll get back a single auto response which has a link to the presentation. So if you're looking for the slides, you can just send an email to that address whenever it's convenient, and you'll get those slides. So next up, we have Atul Saini from Fiorano.
Hello, everybody. This is Atul Saini from Fiorano, and I'm going to be talking about practical and actual microservice-centric integration flows that we've been implementing for quite a while now. So although microservices are quite new, it's not something that everyone's not been doing. There are lots of companies that have actually been using microservices precisely very closely as to how Jason described them. So without all of the discussion that we're going to be talking about over the next 20 minutes is based on practical, real-world experience of enterprise-class projects that have been deployed worldwide in mission-critical environments, both in the cloud and in demanding enterprise environments. So let's jump straight into it. Microservices in practice. Jason talked about fine-grained. I'm going to use the term coarse-grained really for the server process. We found that the best implementation of microservices has been as coarse-grained server processes, which each microservice runs in a separate server process. It is possible to club together multiple microservices and run them in a single process if there are memory issues. But we found that the granularity typically can't be thread-based. So, for instance, in the old days, you used to have VPEL, where every sort of call was a separate thread, and you typically don't want to have a microservice which has got 5 lines of code. That's a bit too small. So, as far as the size of the service goes, a microservice does one thing particularly well, like a database access, maybe 1 or 2 microservices, like a file system access, an FTP system, maybe another 1 or 2 microservices. So we found that in practice, it's all about server level running in a separate process. A critical point is the interfaces. The interfaces are document-centric, so either XML or JSON typically, or data of some kind. You're not going to find, at a practical level, we haven't found in a lot of integration work with microservices, microservices that have an integer, a few characters as interfaces. It's really document-centric. These are very, very critical points. Next, dependencies. As Jason had mentioned, there are no external dependencies in the microservice implementation. Each microservice contains all of the code that it needs to execute. So what this means is that a microservice is essentially each microservice is complete independent of all the other microservices that are participating in the integration flow. This means that think of an integration flow as a set of microservices distributed across multiple cloud environments, in the extreme case, connected via asynchronous messages. They just communicate asynchronously. We'll come to the transport discussion just a little later, right? So in this situation, if one of the steps is slow, if there are no dependencies, you can actually run any microservice on any node. It gives you massive flexibility. That's stuff that you simply can't do today with today's technology, right? So no external dependencies in the implementation, no external dependencies of any kind. And then, as far as configuration goes, there's a GUI attached to each microservice. So each microservice, you have 20 microservices participating in a flow. Each microservice can have a different user interface. This again is very different from traditional application design, where you have a GUI team, a middle tier team, and a database team. So just as you have an independent user interface for each microservice, it is also possible for each microservice to be implemented in a different programming language. So in a single flow, in a single integration flow, you might have a microservice implemented in Java, C, C++, C#, or even scripts. And we've actually seen that this happens a lot in practice. Even though a particular enterprise may be a Java shop, they may need to implement a legacy system in C++ or in C or in C Sharp, and the other way around. You might have a C Sharp shop that wants to implement something in some other language, right? And again, this follows for databases as well. Each microservice can access any particular, for its own usage. Go back to the first point, no external dependencies. Inside the microservice code, one microservice may use SQL as a local data store, another one might use Mongo database, another one might use a mainframe database. This local storage concept of a microservice should not be confused with state information relating to the integration flow. Remember, integration flow implies the flow of information between distributed microservices at runtime when they're being integrated. That state is a separate concept from the data that is stored inside a microservice. It sounds a little bit confusing, but actually it isn't, right? Then, so coming to the concept of integration, what is integration? Integration means you take information from one service, apply a transformation typically, and carry it to another service. Now, the thing is, with the cloud, the services may be in different clouds altogether, or in the same cloud. Or one may be in a cloud, one may be in the enterprise network, one may be in some kind of hybrid environment, they may be in different continents, all kinds of things there, right? All kinds of possibilities. So the most important thing here in integration one has to understand is that the infrastructure plays a critical role. The infrastructure has to have certain characteristics. It can't be completely dumb. You're not going to get away with just using a simple MQ series or RabbitMQ. If you can, but you're going to have to do a tremendous amount of extra work, so you might as well do something a little more intelligent, right? So you need asynchronous transport distributed across cloud and enterprise environments, ideally. Once you have such a transport, you're assured of scalability. You can have parallel data flows across multiple cloud instances, right? You have optimized performance. It's linearly scalable. And remember, you can always build synchronous systems on top of an asynchronous transport, and you can't do it the other way around. One of the big reasons for the extreme cost of existing integration projects for the last 20 years, you must understand that existing integration technology has not changed for 20 years. Whatever anyone might call it with a lot of marketing, even today's so-called cloud-based platforms are based on 20-year-old technology. If you go and look at the application model, it's really, process-centric, and there's a lot of issues associated with it. The kind of things that we're talking about are all fairly new, right? So, coming to the state, the transport has to be asynchronous and distributed, linearly scalable across the cloud. A second important point is the transport has to be designed in such a way that it's got to be able to manage the state of the integration flow. The state of the flow is carried in the messages that are traversing, that are going from one microservice to the other as part of the integration. This state information cannot be stored in any persistence tier. If you have a central location where you're storing the state and you've got 5 different clouds, you're going to become a bottleneck. And so centralized, the persistence tier cannot store state information in a distributed cloud environment. So what does the whole thing look like? If you have an asynchronous distributed transport, this is what you sort of end up with. Essentially, if you've got multiple cloud environments and you've got microservices distributed across these cloud environments, and you're trying to integrate, let's say, 20 microservices, 3 or 4 in one cloud, 3 or 4 in another cloud, and you've got 5 different clouds, you have the notion of an integration pair in each cloud. So the microservices in that particular cloud can integrate through that pair, and so you can have concurrent integrations going on in separate clouds. And if you want to go from cloud 1 to cloud 2, you can go directly. You don't have to traverse a central hub of any kind, which is what you really have to do today. In today's so-called cloud-based technology, you really have hubs. And if you want to scale, you just got to copy the hub. So it suffers from the lipstick on the pig problem, right? You don't have a situation where the transport itself is distributed and scalable. The peer-to-peer integration really allows you to scale very linearly, and you can still maintain control at a single point or at 1 or 2 points, typically at a single point within the network. Control signals are not as voluminous as data flows or as heavy. So control signals can scale from a single point, but data flow really can't, especially in the digital world. With digitalization, data volumes are exploding. You really want to have a situation where you take advantage of as much localization and parallelism as possible. The infrastructure, now we come to a very important point. This is a fundamental issue relating to the infrastructure. Remember I said the infrastructure has to have certain properties if you want to scale linearly across the cloud and across hybrid environments in an integration flow. Well, here's the point. Let's look at the start at the bottom with the core infrastructure. The core infrastructure has to be based on asynchronous messaging because integration essentially means an asynchronous message going from one application to another. That's the definition. A request reply call from one microservice to another is an interaction. It's not integration. So this is something that is missed by most people for a very long time. At any rate, so you have asynchronous messaging at the core infrastructure layer. This has to be organized in a peer-to-peer fashion. But just having raw transport won't work. You see, there are certain common characteristics across the entire integration. And the common characteristics are, in any integration, you have 20 microservices, 50 microservices in different integration. What happens if one of them goes down? You have to monitor. So you have monitoring, tracing, logging, a simple lifecycle management, basic security, and a remote deployment. So the transport has to have a certain level of intelligence, and yet that doesn't make it very, very thick. It's still a thin transport, but it's got a level of intelligence in it. But the most important point is, the infrastructure itself must be composed of microservices. Now, in a typical integration platform today, transformation, routing, caching, these are part of a single central server, a hub. Even in the cloud-based platforms of today, transformation, routing, caching, scheduling, all of these things are part of a single server, right? So if you want to have, suppose you've got 5 different cloud environments, you've got 50 transformations happening in each of them. The transformations typically tend to happen at the hub. Now, what we're talking about, if you have infrastructure microservices, if the infrastructure is organized in such a way that the infrastructure itself is a set of microservices, then you can basically move the infrastructure functionality to the compute point in the cloud. So if you have 5 different clouds, you've got 20 transformations in each of them, the transformation components move to the peer server that's in that particular cloud, or multiple peer servers, and you can execute multiple transformations concurrently. So this gives you a tremendous amount of performance. It scales at the cloud level. And again, the movement of the infrastructure to the relevant point in the cloud across the network all happens dynamically. Now, this sounds like magic, but it really isn't. It's actually stuff that's been working for many, many years in many, many companies. So the core integration infrastructure itself is implemented as microservices. For instance, transformation, routing, aggregation, caching, all of these can be distributed across the network where they are needed. And this gives you the performance that you need to manage the data explosion, the data volume explosion that is starting to happen, that is already happening with digitalization initiatives in the enterprise. That takes us to the benefits of peer-to-peer. The peer benefits are, well, as we've talked about already, there's no single point of failure. That's obvious. Administration can be done from any single location in the cloud. Administration is really not a problem. The only real benefit of centralized architecture, of sort of hub-and-spoke architecture, is the fact that you can administer the network from one location. Well, that's something you can do even in a peer-to-peer network. It's not that difficult. It just takes a while to get it right, right? So obviously, peer-to-peer is very critical for flexibility, for performance, for scaling. Any microservice can actually be deployed across the network. You have a repository of microservices in some location, and as soon as there's a demand for a particular set of transformations in a particular cloud, those are deployed as agents across the network. That means the entire microservice is actually moved to the point and can be executed over there, right? Another very critical point compared to today's technology is that suppose you have a flow with 10 components, and component number 5 in the flow is running slowly. Now, if you're in today's technology, we'll take any product, whether it's, a famous product like TIBCO, IBM, whatever, right? You have a flow, it's typically in a process-centric language. If you've got step 5 in the flow that is slow, there is nothing you can do about it, other than add more cores to the entire server on which the hub is running, which is an extremely expensive proposition. And even in that case, you don't run that individual. You cannot scale an individual step. That might come as a bit of a shocker to everybody, but that's just the fact. Those are the facts today. The microservice architecture is completely different. In a microservice system, you've got 20 different microservices, and the connections between them, there's no process-centric model of any kind. The connections are just asynchronous data flows. So if any particular step is slow, you can take that one particular microservice and run it on faster box. Or you can run multiple instances of that microservice and feed the inputs as required as a distribution component. So you have massive performance benefits, agility benefits. Sometimes these are showstopper problems with existing technology which are solved trivially because they just don't exist in this particular microservice-centric type of architecture. So while the data flow and the execution is all distributed and peer-to-peer, well, it sounds very complicated, but actually it's very, very straightforward. The management of the entire system can be done from a single point on the network. It's not just one point, but you could move the management console wherever you want and monitor the network from wherever you are. So that's the management and the monitoring. As far as the flow composition goes, once again, you must understand, we're not talking about a process engine of any kind or something complex that's executing various process languages. It's just a graph. The integration flow is just a graph that says microservice A is going to send a message to microservice B, C, D, and E, and so on and so forth. So that graph can be composed, drawn really, in a single location, and at the click of a button, it's distributed automatically. The relevant microservices are distributed to the relevant nodes, and they start up on those nodes. If they're not already on those nodes, they're sent then on demand. And the message queues are created dynamically on the fly by the system. So it's essentially like the system is essentially like doing manual JMS programming, except that that's all done for you by the system, right? So runtime data does not reverse the central hub. Only administration information comes to the central hub, and runtime data is as much of it is parallelized as possible. So what does the whole thing actually look like? So basically, you have a single point of control, and you've got multiple peer servers at different points in the cloud. Each cloud will have one or more peer servers, a hybrid cloud or enterprise environment. It all depends on your data volumes and your scaling. And you can have peer-to-peer data flows across multiple microservices, and all of this information is managed from a single location. So the characteristics are that it's distributed, the interfaces are document-centric, the state is managed in the messaging tier. You don't need a separate database somewhere else to manage the state of the system, right? It's very loosely coupled, so whenever you have a slow step in the integration, you just run it on a faster box. It's fully asynchronous, message-driven. So those are the real characteristics. Very simple. It's as simple as it can get. There's no process-centric languages to learn, no central points of control, no hubs to manage, and the costs are significantly lower. From a business standpoint, what's the value that all of this technology brings to you? Really, it's just a simplification. As Jason mentioned, microservices are SOA done right. You put some restrictions on. The problem with SOA was people couldn't even decide what the interfaces should be. You get a big consulting company coming in and saying, you need 500 interfaces. You pay us $5 million and we design 200 interfaces for you. Then you spend 5 years deciding what the interface should be. That's all out of the window now. A typical microservice doesn't need more than 3 or 4 interfaces or just like, 2 inputs and 1 output. We found that in practice, keeping things simple works. Think of a microservice as a Unix pipe with inputs and outputs. That's a great analogy, and it works perfectly. So what's the business value? You cut your time to market. When there's a change in your business, your IT systems suddenly start responding incredibly fast, and you don't have to stop anything. We're just going to talk about a very simple case study for a minute where they're rolling out new business services on a weekly basis, not stopping anything, and everything's happening in real time. So it's almost like nirvana, and it's a lot simpler and cheaper, right? Because of the inherent design of the system, your time to market is cut down. Your costs are a lot lower. The productivity, if you've got, a certain budget for services, it's not that the services vendor doesn't get any services, it's just the services vendor ends up doing 5 projects for the same cost instead of 2. One of the reasons for the big cost of integration is that services vendors are in no hurry to get highly productive technology because it works against the business model, right? So the end user really has the initiative now to get things going in terms of adopting this new technology, which is actually simpler technology and far more powerful. It gives you the agility. You got to make a change. You don't stop the existing system. You make the change, add it to the system, and it works perfectly well. So let's talk about a very quick case study. Delaware North is a multi-billion-dollar company in the hospitality business. They manage events worldwide, like all kinds of football games in the United States. Boston Bruins, they judge football games, basketball games, baseball games. They famously manage the Emirates Stadium for the Arsenal football team, Australian Open, various other things. But basically, they need real-time analytics, real-time information on what's going on, how many burgers are being eaten, how many beers are being drunk, et cetera, et cetera. And they had real-time enabled the entire system, and their CIO is very, very happy. There's a full interview with Kevin Quinlivan in Jason's article in the Forbes magazine, and you can get a copy of this by getting a copy of this presentation. So just very briefly, what were the challenges and what were the results, right? Classic challenges. I'm sure a lot of enterprises, all of you, probably have these challenges. Unstructured data, manual data processes, don't have real-time information. When I ask for something, my IT team asks me to wait for 3 months. We're talking a lot of banks. This seems to be a perennial problem. Right? Disparate applications, can't connect them. It used to take me 1 month to do things, now it takes me 3 days, right? So basically, they now have a real-time system. They're rolling out services on a weekly basis without stopping the system, and everything is scaling just beautifully. It's a fully cloud-based implementation running on Amazon, and so it's just a classical match for today's talk. So the digital business, just to talk briefly about Fiorano, it's a digital business platform. It's microservices. Subsumed the microservices. Everything that we do is based on the microservices concept. Everything that you talked about today has been actually in production for many, many years, and it's stable. And it's just that there was no term called microservices to describe what we do, and now there is. Right? API management. That's for another day. So with this, I'm done. I'll just pass this back on to Tom Stack. And we'll go from there.
The first question we have is from Joshua. What does high cohesion really mean? I think it's subjective. I think this would be for Jason.
Yeah, well, I mean, there are different levels of cohesion. So, I mean, high cohesion basically means the principle that you want one, you want each microservice to do one thing and to do one thing well. So actually, to help answer this question, I see another question from Naimish. He asks, or she, I don't know, asks, if we need to aggregate multiple data sources, should we create separate microservices for each data source, or even when the service is basically the same? So here's the question. So you could build one microservice where you feed a parameter to the microservice that tells it which data source to use, and then you can have one microservice access multiple data sources. Or you could just build a separate one for each data source. So building a separate one for each data source might mean a bit of extra work because you have more microservices to build and more to manage, but they will be more cohesive because now each microservice is simply responsible for providing the access to the single data source. So the reason why that's useful is because of the question of change, right? Whenever you look at something, you want to ask, well, what if things change, right? So in this case, what if your data sources change? You have a new one, or one changes its, you want to change the queries that, that are underlying the accessing the data source. Well, if you have a situation where one microservice is accessing a dozen data sources and you want to change the query for accessing one of them, well, now you have to worry about, breaking the access to the other ones, and it can become this big mess. But if you have a different microservice for each data source and you need to change one of them, well, that's relatively straightforward, and you're not going to impact the others, right? So even though building more microservices possibly means more work and increases your management headache, generally speaking, that is a better thing to do. But you don't want to go overboard, right? You don't want to have so many microservices that you come up with this management nightmare. So there's always there's always a balance. But that essentially gives you an idea of what cohesion means, right? You want each microservice to do just one thing and one thing well. And if you want to do more than one thing, you want more than one microservice.
So I hope that answers that question. And if not, please put another question in the chat box, and we'll try to get that resolved. Another interesting question, and Atul, I'd like you to take these two questions actually, because they relate to essentially the same topics. And the first question from Kieran is, how difficult or easy is it to convert a typical existing system into microservices-based system? And on top of that question, or along with that question from Quebec, where do you handle complex workflows in the world of microservices? Well, Atul, if you could take those two for us, that would be great.
Sure, I'll take that. So how do you convert an existing system? The first thing is you really have to think of components. The existing system is monolithic. You're going to have to split this into a set of components. You draw some components out on a pad, right? And then these components are sending messages to each other. It's major surgery, if you will, in a sense, right? You've got to take the functionality. There's two aspects to the question. One is you might have an existing system and you want to, it's not too complex, you want to convert that particular piece of code into a microservice. So there are straightforward ways to do that. You need to decide what the input and output interfaces should look like. Typically, they should be document-centric. You're going to have data coming in, let's say, an XML or JSON format. JSON is a good format to use because if you use JSON as the format going across multiple services, then it's just the data that goes, and you don't have to perform too many transformations, so it ends up being faster, right? But yeah, if you've got a very complex system like a big business monolithic application, then mapping it to components is not particularly easy. You may not be able to reuse a lot of the code that you've got, but if you can reuse some of the code, then each individual element of the code can be converted to a separate microservice, and it can be in any language or access to that code. So if you have a legacy system, for example, how do we access a legacy system? You can write a microservice to access a particular legacy system. You might have 5 microservices accessing different parts of the legacy system and abstracting the functionality. Right? You might have, say, a C++ microservice, a C microservice, and a Java microservice, all accessing different parts of the legacy system and extracting certain functionality. So as far as the implementation of the legacy of the microservice goes, it doesn't quite matter because internally, the user sees the microservice having an input or 2 inputs and an output, and the user just sees that. The user doesn't understand that as soon as you go into the microservice, it's actually accessing some legacy system sitting on an IBM mainframe, right? So that's the benefit of microservices. You have the flexibility to decide what kind of services you want to create.
Right. Okay, I think that's good. We've got a couple more questions, but to summarize, I think to say that we can, in essence, microservice enable some of your existing applications
Right.
and processes into our system would be one way of moving from your current system to the Fiorano-based microservices system. And we suggest,
Right.
in most cases, that we do a demonstration with some of your use cases and illustrate to you how that would occur. As far as complex workflows, we can do the same, but they can be handled.
Complex workflows is exactly that. So let me talk about that, Tom. Complex workflows means every flow consists of 10 or 12 microservices. You have multiple flows, and each flow can actually pass messages to another flow. So in practical implementations, we found that it doesn't make sense to make a single microservice flow with 500 microservices. That is not a sensible thing to do. It's not easy to manage. It's not easy to run and distribute. It's better to use multiple flows, and there are ways to call flows, get information from one flow to the other. It's a very straightforward process, but essentially componentizing everything. Go ahead, Tom.
Okay, so the next question from John is, how do you recommend approaching applications or legacy systems with no integration tier when building microsystem-based integration solutions?
Perfect. This is related to the previous question. You got a legacy system. You don't know what code is inside. Typically, the legacy system will be picking up or writing information out to a file or picking up information from a file. So one of the ways you actually microservice enable such a system is really you've got to see how the legacy system is interacting, what data formats it uses, and you can use file-based, or you can use the file microservice to send information to the legacy system and create certain outputs, and depending on the data that is created by the legacy system, extract the output, right? If you have programmatic access to the legacy system of some kind, maybe it's got some APIs, maybe by calling a particular C function or by using a particular programming language, you can get access to some of the internals of the legacy system. Well, you can write a microservice using that particular language, right? So those are the ways in which really access the legacy system.
Right. In the case of, as an example, when Atul spoke about ENC, that is exactly what this question addresses. This was a company that had no integration layer at all in their architecture. And we were able to basically microservice enable that first major applications into production within 90 days, and have been adding essentially on a weekly basis microservice-based services for the last nearly 2 years. So this is a very good example of starting from scratch and, getting to a very complex state of integration, if you will. I think that we're on time now. I don't know if there's any other questions, Abhishek, that you'd like to have addressed, or any other comments from Jason or Atul before we break.
Yeah, I would add one comment on the last couple questions having to do with really the decision between legacy migration versus legacy integration. And this has always been one of the central challenges with enterprise IT is, do you move from something old to something new, or do you keep what's old and integrate with it? And it'll depend upon what you're trying to accomplish, right? Microservices gives you some new, more flexible cloud and container-centric tools for legacy migration, but you have to keep in mind that building an app following the microservices architecture will look very different from whatever that legacy app looked like. So you don't want to say to yourself, well, we're going to take this old app and we're going to, turn it into microservices and it's going to work the same only in microservices. There's no point in using microservices that way, because if you take a microservices approach, you'll be able to build a very different kind of app that is much more cloud-friendly, much more digital-centric in terms of end-to-end diverse customer functionality across multiple touch points, right? So if that's where you're coming from, you're saying, well, we need to take this old legacy app and we need to give it a mobile interface and a tablet interface and this and that and the other. Well, that is, you're going to change that legacy app by doing that. Different situation is where you have a legacy app and you want to keep it And now it's a challenge of integrating it and dealing with the limitations of the legacy environment. Often the legacy environment doesn't scale as much as you need to. And it really depends upon what you're trying to accomplish there. So, for example, I was talking to one company who had this old app written in Fortran. So it was ancient, but it had this great business logic, and they wanted to turn it. They wanted to give it a mobile interface, and it's like, well, this thing doesn't scale, right? It's built to be essentially for it's a single user app, and how are you going to give it a mobile interface? And what they did is they took the whole thing and encapsulated it into sort of with a modern, encapsulation mechanism, and then they were able to basically duplicate that legacy app as many times as they needed to. So they horizontally scaled the entire thing. So they just duplicated the running execution environment as many times as they needed to support as many mobile interfaces as they had. That doesn't solve every single problem, and that's not a microservices approach, right? Because now they have this whole Fortran executing Fortran running in a container, and that's not microservices architecture. But that may be what you need. It really depends upon what you're trying to accomplish. What microservices brings to the table is a way of essentially providing the benefits of the cloud and container environments, the horizontal scalability and the agility, and the benefits in terms of processes that Atul was talking about. That really changes what your legacy environment can do. But again, it really depends upon what you're trying to accomplish.
Okay, the next question from Rameshwar. We have built a huge middleware platform and spent thousands building web services. How can we introduce microservices without causing a disruption to the business?
Well, that's actually quite easy. Microservice architecture essentially is about asynchronous flows between microservices. So if you've got a lot of web services, right, you can actually create, in a sense, a web service is a way of calling something, right? So you can create a microservice out of each web service, out of a collection of web services, and then use these microservices in an asynchronous flow. And that works really well. We've done that many times. So in a lot of times if you have, say, 20 microservices in a flow, one or two may be web services. But as far as the flow is concerned, they become microservices because the user doesn't really know. So the process works really well, and we can sort of demonstrate this for you. Then you get all the benefits that we talked about. Go ahead, Tom, ask the next question.
Okay, sorry. The next question from Tana. Gartner states explicit dependencies on other microservices. How do I perceive this comment?
Can you repeat that again?
It says explicit dependencies on other microservices. How do I perceive this? What do we mean by that?
Explicit dependencies on particular microservices. Are they saying one microservice has dependencies on others? Is that what they're saying? It's not very clear. Just the word explicit dependencies on other. Well, from a purist standpoint, at least in our practical implementations, and we've talked to Gartner about how microservices are implemented. I mean, a microservice is an independent piece of code. Now, if in that independent piece of code internally you're calling 3 other pieces of code, that's fine. Then that really becomes, as far as the particular microservice goes, that's part of this microservice. If I want to take this a particular microservice and move it across the network, ideally it's got to move in a way that it doesn't result in too many synchronous calls going to some single point on the network. So the concept of explicit dependencies, it really goes against the exact trend of microservices, if you ask me. It depends on how Gartner wants to define it. If Gartner wants to define microservices as being very fine-grained, then you're going to end up in a religious war which people started in the 80s. The concept of fine-grained versus coarse-grained go on and on and on. And to be honest, a lot of analysts spend a lot of time trying to create more confusion. The situation is very simple. You have coarse-grained interfaces. It works. That's our approach. And we're talking about practicality. We're not talking about theory. We're talking about real-world working production systems. It's best to stick to a notion where a microservice has all of the code that it needs to execute. So if it's got some dependencies, then those dependencies really have got to be part of the packaging of this particular microservice. I hope that answers the question.
Okay. And another question.
Yeah, I mean, well, hold on. Let me add a bit to that. I mean, you can run more than one microservice in a single container if you wanted to. And then essentially that group of microservices can have internal interdependencies, and you can scale the entire container now horizontally, and that would scale that whole group of microservices. And there's nothing really wrong with that as long as that meets your needs with the understanding that that group of microservices in that one container has less flexibility than if you were to run microservices in separate containers. Because if you have microservices in separate containers, then each one is independently scalable, right, as opposed to being in a particular group. So if you have microservices in separate containers, then the way they should interact with each other is via the asynchronous message traffic that Atul is describing, and then that's fine. And then you won't have the explicit dependencies because we're abstracting the dependencies, right? We could have if one microservice A in container A talks to microservice B in container B, and then we want to scale up container B because we need 50 of them instead of 2 of them, then we can do that, and A doesn't care, right? Because A is just sending its message to B, and then the underlying integration infrastructure knows how to route the right message to the right instance of B. Well, that's what we mean by where we don't want explicit dependencies. That isn't necessarily what you want. I mean, if you put multiple microservices in the same container, you'll get better performance, but you'll limit your flexibility, and that's an architectural trade-off that you'll have to make as part of your application design.
Right. Well, just to add to that again, having dependencies within the microservice, you can use multiple instances of the service and act like there are no dependencies, but under the covers, if you're calling the same microservice, it's going to have those explicit dependencies, and if all those dependencies are calling a single piece of code, there'll be contention at runtime. So there's really no magic to it. You can abstract, and the microservice architecture will allow you to abstract away the problem, but that doesn't mean the problem is going to disappear. So that's very key.
In the same vein, we have a couple of questions that just come up in this discussion, and if you don't mind, I'll ask both questions. It's from Gil Perry, and then Atul and Jason, you can weigh in here. The first question is, you mentioned there should be no external dependencies. Does this include composing new services using endpoints of other microservices? We can take that one now if you'd like.
No, it doesn't. Composing new microservices is not an external dependency. Really, it isn't. I mean, because you got an existing set of microservices. It depends on whether you really want to compose. You got to really think about this. When you get some practical experience, you actually realize that we've done some very complex integration projects using all of the things that we talked about. And it's very, very seldom that we got to compose a microservice that calls to existing microservices from our palette. Chances are that will never happen. In theory, you might think it happens. In practical terms, we've never really seen it happening, right? You try to compose a microservice which calls 2 or 3 others. You see, I can see where people are coming from. People are coming from the world of programming. I've got this function call. I want to call 2 other functions. Well, you have to think of microservices in terms of independent server processes with asynchronous communication. So they're big enough in that you typically don't have to compose 2 of them together. It's not BPEL, guys. Don't make the same mistakes that people made for the last 25 years and made integration so expensive. We've been trying really hard to make it easy. And microservices really makes it easy. So you have to change your religion, really. That's really what it's all about. Or drop all programming, drop the religious programming from the brain and just start something new.
Okay, so on that same topic, if microservices are communicating async, I assume this means if using RESTful interfaces, you are just using REST as a sync-async bridge.
Yes, in a sense, you think you're using the REST interface. You don't always have to use REST as the interface. You could even use JMS as the interface. If you really want to do, if you want high performance, think of Unix pipes. Message comes in, document comes in, process it, throw it out. The transport takes it somewhere, right? Now, if the particular microservice itself has to be called in a synchronous way, you can use a REST interface for it, right? Or the bottom line is documents need to come into a microservice, they need to be processed, they need to be thrown out. The microservice itself doesn't even know that it's participating in an integration flow. Get this. This is very interesting. When you actually see an integration flow, the microservice itself, as far as each individual microservice goes, the microservice, when you see it executing, it's just a pipe. Data comes in, data goes out. Now, the external system decides what to do with the data, which is what we mean by the word message managed state. The state is managed outside of the microservices, right? So, again, why are integration systems slow? What is the problem of speed? Synchronous calls. If you take 20 microservices and just make a lot of request reply REST calls, yeah, you get a system that works, but it's no different from web services. It's not a very sensible thing to do. You can do it, it'll work, but you're going to get bad performance, right? So you need to use the asynchronous concepts if you want performance. It's all tied together. The whole system works together. The asynchronous transport, the distribution, the peer-to-peer, the microservice concepts. When you put them all together, you get incredible real-time agility, efficiency, etc. You take out one of the things and then you know, it's like driving a three-wheel car on a racetrack around Silverstone or Spa or something, some famous track.
Okay, another question. Thank you, Atul. This is from Tana. If the state is managed in the messaging tier, do I require an ESB?
Not necessarily. It depends what you call an ESB. The term ESB has become extremely sort of wide. What you need is a message-driven system with some messaging, like so JMS is a standard, so we can use JMS as an example. JMS plus, if you go back to the slide that talked about the slight additional features you need on top. You need tracing and logging, you need monitoring, a little bit of lifecycle management and deployment. You don't need, the key point is, you don't need the transformation, the routing, the content-based routing, the scheduling, the caching. All those ESB features should be managed as microservices, right? They should not be. If you get a full-blown ESB, again, it's like taking sort of like a 16-wheeler truck to do grocery shopping. You can do it, but it's not a very sensible thing to do.
Yeah, I'd like to add to that. It really, you know, the term ESB, you know, in the early days, it was like a catch-all for any middleware vendor who wanted to add web services to whatever old technology they had. And if you look at, say, take for example the Oracle ESB, it had essentially thread managed state. You know, it would spawn a thread and keep track of the Beeple instance, and so it didn't scale very well. It was a central model, you know, it was a hub and spoke model, and it, you know, if you wanted to, you know, persist these threads, well, threads are short-lived, so you had to dehydrate the threads, right? Write the thread state to disk and then rehydrate them. And if you've ever worked with the Oracle ESB, like 3/4 of your time is just monkeying with that damn thread management. It was a big hassle, and it still is if using a product like that. So I remember talking to the Fiorano guys back, you know, around 2004, 2005, and it's like they were doing message managed state back before anybody even knew why it was so important. It's a very different architectural approach. And yeah, the Fiorano guys called what they were doing an ESB back in the day because that's what everybody was shopping for. But they've always been architected differently from a traditional centralized hub and spoke ESB. And in large part because of this message managed state, as well as the peer-to-peer architecture that Atul was talking about. But this message managed state is so important for different reasons. I mean, one is now, you know, what we're talking about in terms of microservices, a microservice, as Atul said, doesn't know if it's part of a flow or not. That lack of knowledge is that state knowledge, right? It accepts inputs, it sends out outputs, whatever it's supposed to do, and it doesn't know the broader picture, right? Because it's not maintaining any state information about the broader message flow or the broader workflow. That is a fundamentally important part of the story, because if an individual microservice goes down, no state information is lost. Then you also have to think about the broader notion of elasticity, right? You don't necessarily, if you have a microservice, you don't just have one instance of that microservice. You have as many instances of it as you need, and the number of instances can change over time. But they're all essentially identical, and now you don't want each individual microservice to have any awareness that it's not the only one of itself that could respond to a request. It doesn't need to know that. It's the messaging infrastructure that keeps track of that, right? So if a message is going from A to B and B has a problem, and now the message has to go to somewhere else, another instance of that microservice, if the state information is in the message, then nothing is lost and things just move right along. And because we're dealing with asynchronous flows, we still have high performance, even though we're making these decisions about which instance is responding to which request at which point in time. And you can't do that unless you have message managed state. So now all of the traditional ESB vendors are busy, either waving their hands or re-architecting their technology, essentially to be more cloud friendly. I mean, you just can't use these other, middleware-centric ESBs in the cloud because they don't deal with state properly. So it's a fundamental difference, and between what Fiorano was, I don't know, they must have been psychic back in in '95 when they came up with these ideas, because here it is in 2015, and we need this capability, and they've been building it into their technology all along.
Yeah, just to add to that, you don't need an ESB in the traditional sense of the term. You can think of this infrastructure as distributed JMS with cool tools. That's the best way to call it. It's got nothing to do with what classical ESBs do. It's distributed JMS with cool tools, right? And components. And those components are microservices. And you saw the palette, right? There's transformation, compression, routing. All of those are just microservices. Make them dance anywhere on the network, and you've got what you want. And you can call it an ESP, call it intelligent JMS, call it whatever you want. It doesn't quite matter. It was very difficult to get the right terminology. I mean, our problem 15 years back was to find the right terminology. ESB came along, so we said, yeah, we're an ESB. So if someone wants to call us a digital business platform, let's call us that. It doesn't quite matter, really. As long as the point gets across that it's about distributed microservices, and the infrastructure has to have a certain level of intelligence, got to have some monitoring capabilities built in. You got to be able to manage the system, et cetera, et cetera. Go ahead, Tom.
Right, and I think for all of us on the call who would like an extended discussion on this, the best thing to do is to arrange a product demonstration with Fiorano, which takes less than an hour, and we will show you exactly how the system works, and then you will understand the paradigm that we're using in terms of delivering on microservices. So I think we can follow up on that. There's another question that's interesting here. I think we've answered a couple of them from Joshua, and this is more industry-specific or vertical-specific. How do you see microservices used in healthcare?
It's very similar. Really, the whole microservice concept is fairly industry agnostic. We're doing a project in a very large government healthcare institution in the UK. And as far as the use goes, it's fairly generic. You're talking about database services, file services. It all boils down to that, right? I've got to get a single patient record. I've got to get the patient record updated, et cetera, et cetera. But those business terms ultimately all boil down to using 5 or 10 different microservices, multiple instances of those, and calling them. So what typically happens in healthcare is that healthcare is not a very high-tech industry, and they use very slow systems in general, and so they have performance issues. But it's not because of the microservices, it's usually because of the hardware decisions, to be quite frank.
Yeah, and
so it's really not a big deal.
And I think I'd like to add to that because I'm out in the field looking at these opportunities over time. And essentially, Atul's correct. Healthcare has a lot of what we'll call legacy systems, whether that's governmental or with the large healthcare systems applications that are out there, and to mention Cerner and others like that. And there's so many different areas that are, addressable in healthcare as far as, from the basic technology on the bedside all the way up to the major systems that are required. But having said that, we are seeing what I consider to be somewhat of an evolution, because I don't want to say revolution, but we're seeing far more activity in healthcare in terms of trying to adopt systems that make communicating between the variety of systems that are in healthcare easier. And we, for instance, have, as Atul mentioned, NHS in the UK is a large customer of ours. Their entire mantra and their entire marching orders in terms of their systemization going forward is to make system integration, for lack of a better term, easier for all of their systems. And so it's kind of out with the old and in with the new, and we're working with them in a number of areas there. In some other areas, we're working with clinical systems, clinical as far as laboratory systems, and again, it's the implementation. We have, large governmental organizations that need and require data, and that data has to be more or less real-time available to them, not to mention that you need the information from the provider to the test labs as well as sent to the governmental healthcare agencies. And we've been helping a large lab company basically create very quick, if you will, microservices architecture. And this has been going on for over a year now, and we've had many successes. And we're still working with them on new projects where they can get information more quickly, more easily, and with a lot less cost than they previously could. So in any case, it's a marketplace that's growing for this technology, and I think it's a very good marketplace if you're interested in taking it further. We have another question from Praveen, and this may have been discussed a couple of times, but we'll ask it specifically. If there are no external dependencies allowed in this architecture, then how can one service utilize other services functionally? And Jason, I'd like you to take that one if you could.
It's actually very easy. We've done this many times before. Just 1 second, Jason. It's very easy. One service can call the other service either via an asynchronous message or via a request-reply call, just as you do in normal programming. You see, one service calls the other service. As far as the second service goes, it's just data input, and it replies blindly. It doesn't know it's being called by the first service or by the third service or by the fourth service. So you can call. We're not talking about external dependencies. What we're saying by no external dependencies, we're saying that the code inside the microservice typically will not call. It's like the call happens through the external interface of the microservice. Suppose you have a microservice with 2 inputs and 1 output, right? You send a data element on the output, it goes to a second microservice and comes back to this one's input. That's how the whole system works. It works very well in practice. Go ahead.
Thank you. And then we'll end it on this question because we've answered most of all the questions. So from Frank Peters, so how would you microservice relate to the middle tier? If you separate the business logic into each microservice, how would you use the microservice in asynchronous calls? Jason?
Well, go on, Jason.
Yeah. Well, no, go ahead. I'm not sure I have anything to add, but go ahead.
It's a straightforward thing. The business logic, I mean, the infrastructure already consists of a number of microservices, right? Transformation, routing, caching, database access, blah, 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 right? The so-called business logic of traditional applications is just really the collective logic that is stored in all the microservices across the system. All you're really doing is splitting up the entire application into a set of objects, if you go with the object-oriented programming concept, except that these particular objects are really large, they run their own processes, and they typically communicate via asynchronous messages. So the business logic is there. It's not like it disappeared. And you need to decide if you're writing, say a particular, let's say you're writing a spread betting application. So you'll have to design your microservices. One microservice is going to sort of follow particular bets. The other one's going to do some gambling, blah, 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 right? The other one's going to do some trading. And you're going to have to decide which business logic goes into which microservice. Then you'll have to use certain infrastructure microservices for speed and for transformation, etc. You decide how you want to deploy this across which networks, and then set up your infrastructure with multiple pairs in different locations, and then you're ready to rock and scale for the next 8 years, 10 years. It's no problem.
Okay, thank you, Atul. So we're having a diminishing capacity now as far as our attendees. It's 10:28. We appreciate all of your time. Again, if you have any questions, you can address them to the to our team here. We provided the different URLs and addresses for that. So please, by all means, send us any questions. And if you'd like to arrange a demonstration of the Fiorano product, which I highly recommend because it does answer a lot of questions in a very short period of time, we will arrange that for you. So once again, thanks for your attendance today. Thank you, Atul. And thank you, Jason, very much for your kind words and your thoughts. And we'll hope to talk to you soon. Thank you very much. Bye for now.
Thank you very much, everybody. Thanks for your patience, and thanks for attending. And you can always call us or send us an email, Jason or us, and we'll go from there. Thank you.